What's up, legendary learners? Mr. R here. When you hear the words rational and irrational, what do you think of? Maybe decision making comes to mind. For example, in a hurricane, it would be a rational decision to hunker down and stay safe indoors. An irrational decision would be to grab your surfboard and go try to catch some gnarly waves. Just like human actions and decisions, numbers can be rational or irrational as well. But unlike certain human actions, irrational numbers aren't crazy or anything. They just have a unique decimal structure. In this lesson, we will explore what makes irrational numbers so special. Let's dive in. Before learning about irrational numbers, it's first important to learn what a rational number is. A rational number is a number that can be written as a fraction where the numerator and denominator are both integers and the denominator isn't zero. For example, 1/3 is a rational number because it can be written as a fraction. But what happens when we convert this fraction into a decimal? All numbers, including fractions, percents, and square roots, can be expressed as a decimal. We can express any fraction as a decimal by dividing its numerator by its denominator. When we divide 1 by 3, we get 0.3333333, which goes on forever. Notice that this decimal repeats itself. This is a key characteristic of rational numbers. Their decimal expansion either repeats or eventually falls into a repeating pattern. Not all repeating decimals are as simple as 0.333 repeating. Some, like 4/7, have longer repeating sequences. When we convert 4/7 to a decimal, we get 0.571428571428 repeating. The number group 571428 is what repeats over and over in this example. So no matter how complex the repeating pattern is, as long as it does repeat, the number is rational. Irrational numbers, on the other hand, will never experience a repeating decimal pattern, no matter how far they are expanded. Their decimal expansion goes on forever without ever repeating. Also, unlike rational numbers, irrational numbers can't be written as simple fractions. The two most famous examples of irrational numbers are pi and the square root of 2. No matter how many digits we look at in the decimal expansion of pi, we'll never find a repeating pattern. That's what makes it irrational. It's impossible to express it as a fraction of two integers. The same goes for the square root of 2. Its decimal expansion is non-repeating and infinite, so it's also an irrational number. Let's review. In today's lesson, we learned about what makes a number rational or irrational. Rational numbers are any number that can be written as a fraction where the numerator and denominator are both integers and the denominator isn't zero. All numbers, including fractions, percents, and square roots, can be expressed as a decimal. Expressing a number as a decimal is an important step towards discovering a key characteristic of rational numbers, that their decimal expansion either repeats or eventually falls into a repeating pattern. Irrational numbers are those that will never have a repeating decimal pattern. Their decimal expansion is non-repeating and infinite. The two most famous examples of irrational numbers are pi and the square root of 2. So there you have it, legendary learners. Irrational numbers aren't crazy or reckless. They just have unique decimal structures that never want to repeat the same pattern twice.